All right, we're in section 10.3 where we're going to apply properties of chords. So if you recall, we had a term chords in 10.1 notes, and by definition, a chord is a segment whose endpoints are on the circle. So we're going to look at different theorems that are going to help us solve different problems, pertaining to whatever kind of example that they wish us to find. So we'll kind of go through a little bit of the theorems, and then we'll kind of apply those theorems to different questions. So the first one that we have in front of us is Theorem 10.3, where it says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are also congruent. So a minor arc would be something like this, like AB, and something like this with CD. So they're saying here that as long as that arc AB is congruent to arc CD, that only works if and only if the line segments AB is congruent to line segment CD. So, being able to apply this, it says here in the diagram below, circle C is congruent to circle D, so which means we have two congruent circles. And now it says AB is congruent to EF, so on each set of circles we have two congruent line segments. And then they're saying that the arc measure of EF, which is like right here, is of 125 degrees. They want you to find the measurement of arc AB. So because AB and EF are congruent, we can say that they are congruent chords, which means that the circles are congruent, which makes sense because they told us that. So we can say that the corresponding minor arcs AB and EF are also congruent. So since they're both congruent, we can then also say that the measurement of AB is also 125 degrees. Here we have a theorem. It says that if one chord is perpendicular bisector of another chord, then the first chord is the diameter. Okay, so it says here that if QS is perpendicular bisector to TR, then QS is the diameter of the circle. So here it bisects, that means that the distance from TP to PR are the same distance, and they're also perpendicular, which we have the 90-degree angle. And we have another theorem on the next page that is sort of the, I believe, the converse of this. So it says if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So they're saying that if EG, which is right here, is the diameter and it's perpendicular, then we could say that HD is congruent to HF, and they're saying that their arcs are congruent, so we could say that GD is congruent to GF. So looking here, hopefully being able to apply these, it says use the diameter of circle E to find the length of line segment BD. So BD is right here. And it says tell what theorem you use. So it says that diameter AC is perpendicular. Let me do a better symbol for perpendicular. It's perpendicular to BD, so by theorem 10.5, we can say that AC bisects BD and that BF is going to be equal to DF. All right, well, we know that DF is a value of 6, so we can say that BD is going to be 2 times whatever DF is. Well, we know that DF is 6, so essentially it's 2 times 6, so we say that BD is a value of 12. Last theorem in this section, it states that in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So what we have here, it says that if AB is congruent to CD, so I'll draw it. So AB is right here, CD is right here. Those two chords would be congruent if and only if the value of EF is the same as EG. So looking at this, being able to apply it, it says that in the diagram, circle F, AB is equal to CD, which is 12. And they show that on the diagram. They want you to find the value of EF. So EF is right here. So all you got to do is apply Theorem 10.6. Well, we know that those two chords are congruent. They have the same measure. So we also know that they are equidistant from the center, which is point F. So we can say that 7x minus 8 would be equal to 3x. So that's where GF is with the 7x minus 8, EF with the 3x, and then we can go about solving it from there. So subtracting 7x from both sides, I get negative 8 is equal to negative 4x. And x is going to be equal to 2, but that's not what they're asking. They want you to find EF. So, EF is going to be, 3 times it by 2, which equals 6. So EF is a value of 6. You can also check it on the other one. So, 7 times 2 is 14. 14 minus 8 is 6. Makes sense. Here it says, suppose AB was 27 and EF was equal to GF, and that equaled 7. They said find CD. Well, if they're saying that these two are equal, which means that they're telling you that those two chords are equidistant to the center, that means that A, B, and CD are still going to be the same value, and that same value is 27. All right, so if we look here, it says if arc TV was 121 degrees, I'm just going to write it in there. It says find arc RS. So we found out that there are two congruent line segments, and since they're both minor arcs, it is also going to be 121 degrees. If you look here, it says find the measure of CB. CB is right here, and BE, which is right here, and I also want to find CE, which is right there. So what they're telling us is that BD is a diameter because it crosses through point A, which is the center, and we also know that EC and BD are perpendicular. So what we can say is by applying Theorem 10.5, we can also say that these two arc measures are also going to be congruent. So since we can make that assumption, we can then set them equal to each other. So we can say that 80 minus x is going to be equal to 4x. So I can add x to both sides. So I got 80 is equal to what? 5x. And then when I divide 80 by 5, I get what? 16. So since x in this case is 16, so I could say that, well, these two are simply going to be what? 4 times it by 16, which is 64. So this is 64 degrees, this is 64 degrees, and I apologize. So the CE is right here. So it's basically, it's just the sum of both of them. So it's going to be 64 plus 64, which is 128 because it needs to be a minor arc. It's not the major arc in this particular instance. And so, yeah, so we have our 3 minor arcs. CB was 64, BE was 64, and CE was 128 degrees respectively. And that is how you apply properties of chords. Hope this helps. Till next time.